Hello students, in this video we are going to see three-dimensional geometry. So you have learned coordinate geometry in your earlier classes. Here we are going to discuss about coordinate axis and coordinate planes in three-dimensional space, coordinates of a point in space, and the sign of the coordinate of a point to determine the octant, and some problems. To locate the position of a point in a plane, we need two intersecting mutually perpendicular lines in the plane. These lines are called the coordinate axis, and the two numbers are called the coordinates of the point with respect to the axis. Similarly, if we were to locate the position of the lowest tip of an electric bulb hanging from the ceiling of a room, or the position of the central tip of the ceiling fan in a room, we will not only require the perpendicular distance of the point to be located from two perpendicular walls of the room, but also the height of the point from the floor of the room. Therefore, we need not only two but three numbers representing the perpendicular distance of the point from three mutually perpendicular planes, namely the floor of the room and the two adjacent walls of the room. The three numbers representing the three distances are called the coordinates of the point with reference to the three coordinate planes. So a point in space has three coordinates. In this chapter, we shall study the basic concept of geometry in three-dimensional space. Here are the coordinate axis and the coordinate planes in three-dimensional space. Consider three planes intersecting at a point O such that these three planes are mutually perpendicular to each other. These three planes intersect along the lines x-ox, y-oy and z-oz, called the x, y and z axis respectively. We may note that these lines are mutually perpendicular to each other. These lines constitute the rectangular coordinate system. The planes xoy, yoz and zox are called the xy plane, yz plane and zx plane respectively, which are known as the three coordinate planes. We take the xy plane as a plane of the paper and the line z-oz as perpendicular to the plane xoy. If the plane of the paper is considered as horizontal, then the line z-oz will be vertical. The distances measured from the xy plane upwards in the direction of oz are taken as positive, and those measured downwards in the direction oz dash are taken as negative. Similarly, the distance measured to the right of zx plane along oy are taken as positive, to the left of the zx plane and along oy dash as negative, in front of the yz plane, along ox as positive and to the back of it along ox dash as negative. The point O is called the origin of the coordinate system. The three coordinate planes divide the space into 8 parts known as octants. These octants could be named as XOYZ, which is the first octant, X-OYZ, which is the second octant. Third octant is X-OY-Z, XOY-Z, XOYZ dash, X-OYZ dash, X-OYZ dash and XOY-Z dash, which are denoted by the other octants respectively. Therefore, we have 8 octants in the three coordinate planes. We will discuss about the sign of the coordinates of a point later. Let's see coordinate of a point in space. Chosen a fixed coordinate system in the space consisting of coordinate axis, coordinate planes and the origin. We associate with three coordinates x, y, z and conversely given a triplet of three numbers x, y, z. We locate a point in the space. Here a point is P in space. We draw a perpendicular PM on the xy plane with M as the foot of the perpendicular. Then from the point M, we draw a perpendicular ML to the x-axis, meeting it at L. Let OL be x, LM be y and MP be z. Then x, y and z are called the x, y and z coordinates respectively. We may note that the point P, x, y, z lies in the octant XO, YZ, and so all x, y, z are positive. If P was in any other octant, the sign of x, y and z would change accordingly. Thus, to each point P in the space, there corresponds an ordered triplet x, y, z of real numbers. Alternatively, through the point P in the space, we draw three planes parallel to the coordinate planes, meeting the x-axis, y-axis and z-axis. In the points A, B and C respectively, let OA equal to x, OB equal to y and OC equal to z. Then the point P will have the coordinates x, y, z. And we write P as x, y, z. Conversely, given x, y, z, we locate 3 points A, B and C on the three coordinate axis. Through the point A, B and C, we draw planes parallel to YZ plane, ZX plane and XY plane. The point of intersection of these three planes, namely ADPF, BDPE and CEPF, is obviously the point P corresponding to the ordered triplet XYZ. We observe that if P of XYZ is any point in the space, then X, Y and Z are perpendicular distances from YZ, ZX and XY plane respectively. Here the coordinates of the origin O are 0, 0, 0 and the coordinates of any point on the x-axis will be x, 0, 0 and the coordinates of any point in the YZ plane will be 0, YZ. The sign of the coordinates of a point determine the octant in which the point lies. Here the table of coordinates in 8 octants. The sign of the coordinates in 8 octants. In the first octant, we have the three coordinates which are positive. In the second coordinate, in the second octant, the first x coordinate are negative and the remaining yz are positive. And in the third octant, we have xy negative and z-axis positive. In the fourth octant, we have x and z are positive, y is negative. In the fifth octant, x and y are positive and z are negative. In the sixth octant, we have x and z are negative and y are positive. In the seventh octant, we have all the three coordinates are negative. And in the eighth octant, we have x positive and yz are negative. Let's see some example. Here the points are given. Here the point P is 3, 0, 5 and Q is -5, -5 and 7. The point P 3, 0, 5, all the three coordinates x, y, z are positive. It lies in the first quadrant. And the point Q -5, -5 and 7, that is x and y are negative and z is positive, which lies in the third octant. So the point P 305 lies in the first octant, and the point Q -5 and 7 which lies in the third octant. Let's see some problems. A point is on the x-axis. What are its y-coordinate and z-coordinates? If a point is on the x-axis, then its y and z coordinates are 0. So similarly, if a point is on the y-axis, then its x and z coordinates are 0. Then the second one, a point is in the xz plane. What can you say about its y coordinate? So again, if a point is in the xz plane, then y coordinate is 0. If it is in yz plane, then x coordinate is 0. Then we will see the third question. Name the octants in which the following points lie. So we will see the first 4 points, 1, 2, 3. So the first point is 1, 2, 3. All are positive. We can say that this point lies in the first octant. And the second is 4 minus 2, 3. Here we have x and z coordinate are positive, and we have y coordinates are negative. Here therefore we can say that 4 minus 2 comma 3 which lies in the fourth quadrant, in which x and z are positive, y are negative. Then the third point is 4 minus 2 minus 5. Here x is positive, yz are negative. That is, it lies in the 8th octant. The fourth point is 4, 2, minus 5. Here x and y are positive and z are negative. Therefore, this point lies in the octant 5. So we will move to fourth question. Fill in the blanks. The x-axis and the y-axis taken together determine a plane which is known as the xy plane, and yz taken together we can say it is yz plane, and x and z taken together we determine a plane known as xz plane. The second one is the coordinates of point in the xy plane, which is of the form x, y, 0. So if the points lies in xy plane, then z will be 0. Then the third one is coordinate planes divide the space into 8 octants. So we have 8 octants of different signs of coordinate system. Thank you, students.